Dodging icebergs in Greenland's Jakobshavn ice fjord is all in a day's work for mathematician David Holland. With support from the National Science Foundation, Holland and his team from New York University are crisscrossing the mouth of the fjord, lowering a probe deep underwater to gather data on salinity, temperature, pressure, and other factors.
The bottom layer from 200 to 290 should be the water coming in theory, which would be the warm, salty water.
Far beneath the frigid surface layer, a deep river of warmer, saltier water is moving up the western coast of Greenland, right to the doorstep of the massive Jakobshavn Glacier. The warm currents shift and change over time. Right now, they are flowing directly toward this region, partly due to natural atmospheric cycles, but almost certainly exacerbated by human effects on the climate.
If you can visualize it, the warm water that we're measuring beneath us here reaches underneath the ice sheet and melts it.
This is an outlet glacier, one of the most active in the Arctic. Ice flows from the land over the fjord, ending in a sheer calving front, where massive chunks of ice cleave off and float away. Scientists have tracked the glacier's retreat for nearly 200 years, but in 1997, that process went into overdrive. For Holland, understanding the dynamics of what's happening here when the warm water meets the ice is key to predicting sea level rise in the future.
The Greenland ice sheet grows as snow accumulates on the ice sheet, and the Greenland ice sheet loses mass as it discharges ice through these fjords. So we're looking at the bookkeeping, if you will. Is it gaining more ice or losing more ice? And in particular, we're looking really at the loss part.
He deploys similar monitoring probes out the side of a helicopter, very near the calving front.
Watch your head.
This mooring is designed to float in the fjord for a year,
There you go.
carrying instruments that will collect data during the dark and cold of winter. Holland says climate models used to predict glacier melting and sea level rise are only as good as the numbers plugged into them, and precious little hard data has even been collected here. The readings he gathers with these probes are critical to fine-tuning those models.
Where we want to go is to be able to project the future climate of the planet just in the next few years or a century. And to arrive at that, we need mathematical models and computational models. But to arrive at that, we need data to drive those models.
Dropping down deep to learn more about climate change and sea level rise, David Holland is working hard to go beyond the tip of the iceberg. For Science Nation, I'm Miles O'Brien.